Welcome to Sairam Triply YouTube channel. Let us discuss Model 2 stability analysis tools. Ability to stable the power system or smart grid. We have some tools for stable operation. So that's a stability analysis tools we are going to implement in the present power system grids, right? And we'll discuss strength and weaknesses of existing voltage and current, right? So let's move on to the topic. Mm, so robustness, so persistence of system, characteristics, behavior, and the perturbations are a condition of uncertainty. See this stability analysis ability to stable the system if suppose any uncertainty occurs or any disturbance occurs, any power failure occurs, it makes the stable operation. Next, scalability, so ability of the system network process accommodate growing amount of work, ability to be enlarged, accommodate growth. So on scalability in the sense ability to scale, I mean suppose starting this 5 percentage, 10 percentage, 20 percentage, 30 percentage, it will be like it must increase, right? So then only the smart grid involvement or smart grid mm, use. So here like applicable. Next, stochasticity, the time development be the deterministic, essentially probabilistic, that is analyzed in the terms of probability. So this smart technology like probability concepts must be there for choosing, right? Next, predictivity, rigorous, often quantitative forecast the what will occur under the specific conditions. So this one is like automatic, intelligent power supply system. So automatic also it will be operating, right? Next, adaptability. The system can adapt its behavior according to change in its environment or in the parts of the system itself. So adaptability is needed for the power system and the smart grid technology, to make a flexible. So it must adapt. And then online real, so real time data acquisition. So previously we had a SCADA and PLC for the monitoring for everything. I mean mm, you suppose some failure occurs, automatically it will get like activators, it will be happening. But here online real time acquisition, instantaneous acquisition of data, right? Next, we have a continuation of this asset management, voltage stability, ability to stable voltage, asset managing the assets, angle stability assessment. So, angle stability assessment you will get it in the generation part, and then designing optimum control. So, we need to control optimum, less usage and then more output, right? So, less usage and then less, I mean, more usage but less losses, or reducing the cost and cost of using but efficiency is more, right? So voltage stability assessment techniques. Now we discussed the selected voltage stability indices, the VIP methods. The methods based on the singular value, decomposition condition, number of Jacobian matrix. See, Jacobian matrix is for to determine stability analysis, right? So the method based on the energy margins also, based on the energy margin also, it will be uh, helpful, right? Next, we have a voltage stability indexing. So many indices characterize the proximity of operating state to the collapse point of view. So have been developed the degeneracy of the load flow Jacobian. See here, load flow in the sense we have different types: Gauss-Seidel method, Newton-Raphson method, um, Newton-Raphson, Gauss-Seidel, and another one is there. Um Runge-Kutta method or whatever, that is load flow studies. Mm, Gauss-Seidel or so there is a number of methods will be there to determine load flow, like Gauss-Seidel and Newton-Raphson method and fast decoupled methods also will be there, but Jacobian matrix also we are using to determine the load flow and index of the power system steady state stability limit. Okay. So finally, the stability of voltage. I mean, like voltage stability analysis. So ability to stable the operation. We have here like active and reactive components are voltage stability indexing, voltage stability magnitude, and different like aspects will be there.